Welcome to another video, the same every time, GCSE Maths, looking at the kind of questions that apart from the numbers are the same every time. And we are looking at three-dimensional Pythagoras and three-dimensional trigonometry here, which you might think of as being a high-end subject. If you're one of these people who doesn't see themselves as a natural mathematician, this might be the kind of question that will put you off a little bit, but it doesn't need to. You can do something here in this question, you can get yourself into the method marks, and a lot of these questions, a lot of what you're going to be asked to do will be exactly the same every time. So we have this diagram showing a box in the shape of a cuboid. A, B, C, D, E, F, G, H, they are just the names of the corners, the vertices. They tell us the measurements, 20 centimeters for A to B, B to C 18 centimeters, A to E 16 centimeters. And we've got this rod going from A through to G through to X, which is 40 centimeters long. So they want us to calculate G to X, the length of the rod which is outside the box. So what they want from us, first of all, is this. So they want that length just there. Well, I think the method for this is going to be to find the length of the rod just there, inside the box, and then the entire length of the rod from A to X is 40 centimeters. So if I subtract the part I've put in blue there from 40, I should get the length from G to X. Right, now, of course, we did say, somebody said that a lot of this is going to be the same every time. My task now is to find the length from A to G. I need to look for right-angled triangles. If I draw in the diagonal of the base, and then I draw straight upwards like that, that angle there is a right angle. And I know that from C to G is the same as from A to E, which is 16 centimeters. So what I need to do in order to find A to G, I need another side, A to C. Well, if you watched the last video, I said that even if you're not sure what to do in this kind of question, the first thing to do is generally a good idea to find the length of the diagonal of the base. So there's the base, looking at it from above, A, B, C, D. There's 20. There's 18, and from A to C would be there, and that would be a right angle. So we have a Pythagoras theorem situation. I want to find A to C, which is the longest side of this right-angled triangle. So finding the longest side, it's going to be square, square, add, square root. So square, square, add, square root, and probably a calculator job for that one. So 20 squared plus 18 squared and square root of that gives me this. So that's going to be 26.907248. And that's the length from A to C. Keep that on your calculator. Never use a rounded answer in a calculation, because that's how you might go wrong. That's a 2. Right, so I need to find the length from A to G, and it's another Pythagoras theorem situation. So A to G, I'm finding the longest side of this right-angled triangle. So again, it's a case of square, square, add, and square root. Well, you should still have the A to C measurement on your calculator. So square that one, plus 16 squared equals, and then square root of that. Okay, so 31.3049516. So that's the length from A to G. But reading the question, that's not what they wanted, is it? They wanted the length from A from G to X, so it's going to be the entire 40 centimeters of this metal, this thin rod, and minus the answer that we just had, so 31.30495, a few dots there. So you should still have that number on your calculator, so 40 minus that. And they don't actually tell me in the question what accuracy to go for, so I'm going to write down my full calculator answer there, and I'm also going to round this. I think I'll round this to 3 significant figures, so 8.695, 3 significant figures. The 9 is the 3rd significant figure. Look at the next one, that's a 5, tells it to round up, so the 9 has to round up to make a 10. So 8.70 centimeters, and that's rounded to 3 significant figures. So the trick with this is basically to look for right-angled triangles within the 3-dimensional shape. And I'll say it one more time, if you're really not sure what it is you're supposed to be doing, then your first move should be to find the length of the diagonal of the base. So draw out a separate diagram of the base, the ABCD rectangle, and use Pythagoras' theorem to find the length of the diagonal. Now, back on familiar territory, I do say it's the same every time, and calculate the angle that the rod makes with the base of the box. So this is worth an enormous 3 marks actually, isn't it? We've done most of the work for this, so calculate the angle that the rod makes with the base of the box. Let's go back to the diagram. And when they say the angle that the rod makes with the base, they mean the diagonal of the base. Well, we've already drawn in the diagonal of the base from A to C, so the angle that they want is that angle just there, and we're dealing with a right-angled triangle. So it's going to be inverse trigonometry. We want this angle. That's the opposite side. That's the adjacent. We've done all the work. So it's going to be tan, isn't it? So to find the angle, that will be the inverse tan, O and A, that's tan. O over A, so 16 over 26.90724. Now, at this stage, I don't have that number on my calculator anymore, the 26.90724, which is why I'm writing down pretty much my full calculator answers here. Never use a rounded answer in a calculation. At least write down the full calculator answer, or maybe 5 digits after the decimal point. Once we're at this stage, this is I think this is a fairly straightforward 3 marks, this. If you know your stuff, because we've already done most of the work for this one. So 26.90724 and inverse tan. So I've got 30.73721, and I'm going to round that to 1 decimal place. 30.7 degrees, that's 1 decimal place. Well, there you are. Maybe not as bad as it looks. Look for the right-angled triangle, the diagonal of the base, the edge from C to G, and then the big diagonal from A to G. That gives you the right-angled triangle. And I'll say it one more time, even if you're not sure what to do, the first move really should be to calculate the length of the diagonal of the base rectangle, because that is quite likely to be part of the method, and you will get yourself into the method marks. So I do hope that video was useful to you, and if it was, then please go ahead, like and subscribe. Thank you very much for watching. I will return for the next video.